Perfect. All right. Class 6. Still got lots more to go, but we're getting through there. It should start feeling like it's becoming a routine, which that's what we're hoping. We're hopefully getting over the initial hump of this is hard every single day to this is just normal. Still hard, a little bit normal. We only have one chapter, and to be honest, they have some very important things in here, but they also have some things that I'm just going to gloss over. And don't think it's because I don't know how to do it. I absolutely know how to. I don't think it's important. So if I don't want you to have to worry about every single topic that is ever brought up in LaunchCode, I'm going to try to prioritize those for you. So that's what I'm doing here. The main two things are anonymous functions, which I will be showing how to do those as arrow functions, and I'll be talking about that. And then recursion, and the recursion is the one that I have never needed to program ever. There are some highly complex systems that you do need recursion for. Again, I was a math major. We did numerical analysis, and I wrote recursive functions to analyze numbers. But that, if you're talking about web development and the basics to get you inside the door to a job, if you need to be able to understand what recursion is, but they'll never ask you, write me a recursive function. It's just not gonna. So the big things, named versus anonymous functions. You can pass function in as arguments. And then map functions, I even left recursion off of here because, again, I'm going to go over it, but it's not, if you don't get it, just don't worry about it. So everything on the top are the named functions that we've done before. For instance, usually would say, hey, I have a function here. That's kind of like let. It's declaring to the computer, this is what I'm going to be setting up for you. I'm going to be setting up a function with parameters. I'm going to do some things. So that's the named one because my name is my function. You can do the same thing without naming it and just say, hey, I got a function for you, and then not put a name. It's the only difference. Now, how we actually use them, we've done function add, and that adds them. Instead of doing function add, I could say, hey, let add equal this function that also takes in these parameters and do the same thing. So I'm hoping you're seeing the similarities there. Same thing on the right. If I wanted to do a set timeout, which all that does is it tells the computer, hey, I want you to do this thing, which in this case is the print message. And I want you to, but I don't want you to do it now. I want you to wait however long. So I think that's like 5 seconds. So these mean the same exact thing. So for the first example on the left, I don't ever see me needing to set it as a variable. I'm going to be very honest. I'm going to even say almost biased or opinionated in these situations. So I'm going to tell you what I've seen in the real world. I'm going to tell you, because you could focus on 100 things, I'm trying to whittle that down to what should you focus on. So I'm going to tell you, you should never set a function to a variable. You can. There might be times that you see that. I don't see that. The one on the right, though, I do see. You see that we didn't set print message. We didn't set this console log as a parameter down here. We just embedded it inside the set timeout. I've seen this. This is the type that you want to do. So if you want to do something, you can just embed the function right inside the other function. So right. Again, I'm not going to go over what they call unnamed functions. I'm going to go over these as arrow functions. So the same function that we talked about just before, we said function add. This is your named function. Hey, function add, and then you can call add later. they said, oh, you can set it as a variable, which again, I probably wouldn't do this way, but I did want to show this additional arrow function. So this thing that I just boxed, you put the parameters that you are using in the parentheses. That's normal. Hopefully you guys see that you've seen that before. And then you put an arrow, which means these parameters are a part of a function, and we are going to pass these parameters inside. Now I'm going to do a lot more of these. So don't think that, oh, this doesn't make sense right now, I'll never get this. No, this is just, I'm throwing it up there as your first look, but I'll do plenty of examples. I think, I'm just making accusations here, I think LaunchCode didn't really show this because a lot of their stuff is a little dated. And this arrow function came out in 2015. And so if they wrote anything around like even 2018, it probably still wasn't the popular thing, but now it is. I rarely see functions written without the arrow function. You can, I've actually seen it both ways, but the arrow function is the fastest way that I've seen. I don't know why it's called a Lambda function, but these Lambda functions are also in any language. So Java has them. They're written just like this. Python has them. They're written just like this. So it's like consolidating different languages on how they do things. I think that's what languages always do. They figure out, ooh, who has the new coolest thing, and then everybody repeats it. So they're all very similar. So once we learn JavaScript and we go to Java, there will be some things that we got to change, but it'll be very similar. So callback functions. To be honest, I just skimmed over the textbook this time. This is probably my least favorite chapter. So I can't remember if they actually called these out by name, but callback functions are just functions that are passed into an argument into another function. Oftentimes, and you will not usually see this in Java. So like in my base language of Java, we don't do this. But in JavaScript, it happens all the time. So it isn't something that I can say, oh, there's ways around it. You will see this all the time. So for instance, JavaScript does these things called asynchronously. Synchronously means that you do things in order, and then step 2 and step 3 and step 4. But then in JavaScript, because you want it to go faster, you can actually load things onto a page in any order you want to, as long as they all get there. So JavaScript does things, they try to do things asynchronously, which means if you call one function and you're expecting another function to get called right afterwards, you're not guaranteed that. So oftentimes they do callback functions to say, once you run this function, I'm guaranteeing that you're going to call this other function afterwards. It's not going to get called whenever you want to. I'm explicitly saying, call this function first, then call this next thing. So when you call a callback function, this is just, you're just going to do a console log. That's all this is. And then you're going to pass this function in as a parameter, which gets picked up by the parameter. You get passed in as an argument, gets picked up as a parameter, and then it actually gets called right there. So this guarantees that the set timeout gets called with this callback, rather than these two getting ran whenever. Again, we're going to do some more live coding. Just trying to set up the skeleton structure for later. Recursion. These are just definitions. Recursion is a programming concept where a function calls itself in order to solve a problem. Oftentimes, you don't know how many times it's going to call itself. That's why they use recursion. That's why systematically some people like it, because you're like, if I might need to call it 10 times, I might need to call it 2 times, I might need to call it 100 times, I don't know. But I know I want to do the same thing over and over and over again until the base case gets hit. So you start with the base case, And then you start building on top of that. You have a recursive call that does something to whatever you're doing over and over again until it gets to the base case. And then it actually like recursively calls back out. The biggest thing that is a problem is termination. I've seen too many times people start with recursive function and they never hit the base case. So then it never terminates and it's like an infinite loop. Another reason why it gets very easy to set your computer on fire that way. So I skipped out a little bit earlier, but that's all I had for the slides because I want to do a lot of live coding. I did want to do expectations. Remember, you'll get attendance code later. You'll have studio. Reading exercises before next class. The biggest thing is the assignment, the graded assignment. And to be honest, there's a good chance that I'm not going to speed through the live coding by any means. I'm going to give it its due diligence, but I've purposely made the lecture kind of shorter so that you guys would have more time for the graded assignment and the studio. So I know how important that is. I'll say my couple motivation remarks. I want every single person that's listening right now to still be listening to me on Thursday. That is my goal. So anything that I can do to help that, let me know. Every single one of you deserve to be here. Every single one of you are intelligent enough. There is no barrier besides yourself on why you can't turn that stuff in tonight, and then I can see you on Thursday. So the only blocker you have is yourself, and that's usually not asking the right questions or not starting or not, being fear and letting fear take over of like, I'm not good enough or I can't do this. Don't let that sink in. That's when you reach out and you get help either from your other classmates or from me. So keep working hard. I need to see all of you Thursday. All right, live coding. I know this is what I like to see it as, but I don't think any of you can see that. So I think this is where we're normally at. I might have to zoom out a little bit for these different things, meaning I had a couple of questions on the exercises. I am not going to spend a lot of time on the exercises. Again, this is not one of my favorite chapters, and it's not because of the topics. It's because I don't think the examples really, in my case, matter. So I'm going to briefly go over these so that you can see if you're curious about them. But these are the kind of solutions. So the first one, this map function is very, very important for you guys to understand how to use this. So I will show more examples of this, but this is the whole reason I want to go over this, to make sure you understand you can pass in an array, and this map, if you remember my handy tool of just hovering over it, what this does is it takes what they call a callback function. So it's not wanting a number, it's not wanting an array, it's not wanting a string, it wants a function. Well, I haven't created a function yet. And I don't want to create a function to then just sit there and get called this one time. So I'm going to make a function on the spot. That's what those anonymous functions are for. This is a perfect example of when to use an anonymous function. And I'm showing it in the way of an arrow function. So if your syntax is just slightly different, it's perfectly fine. I'm just going to show you what I usually see. So the callback function is this function. What I'm saying, hey, there's a function. I don't even give it a name, but there's going to be an element. And that element, I want you to return this practice element, the practice version of this element. Well, what does that mean? Well, the practice method is up here. And again, I don't like how this is. If it was me, I'd just make this a named function and do the function This is how I would write it. That's just me. That's my opinion. I don't want to set it as a variable because then I don't know, is it really a variable? Is it a string? Is it a number? Is it a whatever? If I say function and here, it's there. I know it's a function. I like to keep consistency. So then there's a function here. It's going to take the element of the array, pass it in up here, and then it's going to do some validating. And it's going to say, hey, if it's a number, return 3 times that number. If it's a string, return arg. And if it's anything else, just return that element back. And the map iterates through all of the array, all the elements of the array, applying whatever you stated here to each element. Now, this just does the calculation, does the work, but then you also say, hey, save it back to the array. So if I can get this CD, I'm in more functions, I'm in exercises, then I'm gonna do node practice. So on this, it took this string. It took the string as an this element was the first element. It said, hey, return whatever this is. Well, what is that? Well, that gets passed up here. It says, are you a number? No. Are you a string? Yes. So I'm going to make you arg. That's where this came from. The 21, it says, okay, next up, 21, do this practice 21. Is that a number? Yes. So do 3 times 21, which is 63. So this map function is very helpful when dealing with arrays. I will try to zoom in one more time. Well, I do that, and then my next thing, I'm going to zoom right back out. But all right, that's this practice. I do like this practice just for the mapping part. So hopefully you understand that part. The rate of shuttle, as a teacher, I understand where they were trying to go with this, but I think the description and the execution of what they were doing, I don't think they described it very well because there was a lot of people that got confused. So I'm going to zoom out just a little bit to show you kind of the screen. You do not need to read each individual line, but the main thing was that people were asking in chats, how do I call all of this stuff? This was the suggested part, so I will zoom in here so you can see the suggested call. They named their 2 functions, deck mops and parrot food. Those were their 2, forgot what the words that the book used, but those were the 2 functions that they did. They said, let this array do this, and then they called the fuel level. And then up here, what did deck mops do? It grabs some stuff and push this. So I don't want to go over this. It's too much for us to kind of go over right now, but this is how they called it. Because some people had a question about that. Yeah. And to be honest, if you got lost in the assignment, don't worry. This is not one to worry about. Now let's go to some of the stuff that I've written down. I think some of you have noticed I get a little scatterbrained sometimes. So I've written stuff down. I don't always remember at the time. I mean, I wrote down too much throughout the week. So the main thing that I wanted to go over here is callback functions. So we're going to stick the first half of this on callback functions. This was the exact one that we were showing earlier with the callback. What I wanted to do right. So let's think through this. I declared a function. when I declare it, it does not run. I think that is something you have to know. When you declare a function, it does not run. You have to call it to run. I declared another function, so this one's not going to run either. I'm going to call both of these functions right here. So it should run these, and then it should print this. So let me test my theory here. Again, I switched back out. Yes, okay. So this is where it starts getting weird in JavaScript with timing. The last line says, when does this run? But that actually ran first. And I didn't really show the code, so I will explain it. But this is where callback functions in JavaScript is very, very important, because if I need this to run after this, I have to set it up and explicitly say that. Now, the way I made this not run first is if I go inside the perform options async, it calls this timeout function, which purposely says, don't do this for this amount of time. And the time that is here is 1 second. So this says, do the operation complete. Do the operation complete after 1 second. So that is what happens. It hits this when it starts this operation. It actually keeps running this one, and then the other one comes back after a second. And I think the hard part is 1 second. This is going to sound weird, but 1 second on every computer is actually slightly different. Now, it should be the same, but CPUs run at a certain frequency, and then what they do is they calculate based off that frequency how long it takes to make a second, and so they calibrate that based on your CPU running at a consistent pace. But CPUs actually don't run at a consistent pace all the time. When you overload it, they actually slow down just a little bit. There's also ways to overclock your CPU. So whenever you're doing JavaScript and you're like, hey, do this after 5 seconds, do this after 10 seconds, and if you call them one after another, usually the one that does 5 seconds is going to be called before the 10 seconds. But let's say that you call something up here that says 5 seconds, another thing that says 5 seconds, but you also at the beginning called 10 seconds. Well, you're like, well, 5 and 5 make 10, so the other ones should run at the same exact time. They won't. And you don't always know which one's called which time. So that's why you start getting into weird stuff. That's why asynchronous gets very confusing. It's also inconsistent, which is why they do callback functions, so that we ensure run 5 seconds, then call this function that runs 5 seconds. If you explicitly call it in the function and pass it in as a callback function, then you're guaranteed that it'll run afterwards. So that's the whole premise of callback functions, is to make sure that certain things are synced. Right. I'm not going to go over this per se, but I just wanted to prove to you that these two things do the same thing. So the book says, hey, you can do this. You can say, hey, I got a function and I want to make it to be add. And whenever I call this thing, it returns 4, just so that you know it's not hard coded. If I did 6 and 2, that should return 8. I could write it like this, or I could write it like this. And so no matter which way I do this, it's going to run just fine. This is called a named function. This is an anonymous function that is saved as a variable. Very similar, slightly different. Again, I don't like saving functions as variables, so I would just write the name function. All right. 4 different ways to write this function. We want to take this array and we want to multiply all these numbers by 2. So I'm going to say, okay, here's an unnamed function. I'm going to call the ×2 by mapping each of those things. And then at the end, I'm going to print both the nums, which is the original one, and doubled, which is this variable right here. So nums, doubled. This one is calling ×2 function because remember map needs a callback function. So this has to be a function. I'm going to call that. When I run that, I get the original one and the doubled one. So you can do it as a variable. You can do it as a function and throw in the function. And it works. You can also, instead of letting double equal the map and then calling a pre-made function, this is, I think, the way the book has you do anonymous functions inside a map like this, which is perfectly fine. That, again, the main difference is that they declare a function. It's a lot cleaner if you still have to have the parentheses. So anytime you see a parentheses by each other, whether it has an in it or not, that means it's a function. So in here, it's just instead of having a function and then also doing the map, I'm including the map with the function inside of it. So this thing here does the same thing. It doubles the numbers. But my favorite way is this bottom one because it uses the arrow function. So again, here's the difference. I want to make sure I'm going to uncomment this so you see the coloring scheme. It says function. If you use arrow function, you don't have to. And that's pretty much the difference. That's the only difference. Instead of saying function, you put arrow afterwards. But again, to prove to you that this works, it works. Yeah, so Christina, yeah, you just need the parameter in parentheses is always best. I think I've seen it without the parentheses, but that one I don't think is as readable. I like to see the parentheses naturally makes my brain think of function or method. So I really like the parentheses to throw, because that's what you usually see as parameter with parentheses around it. So really like those. Fine. Somebody else, I can't remember if it was this one or this other one. We get to bring back in our readline sync, right? So what this is doing, the inputs requiring readline sync. So we know that when we get down here, we're going to get user input. There's going to be, it looks like 3 questions. The answers are going to be stored. And this is going to take the questions and do the map. So it's going to iterate over each question. And it's going to take the question, which is the element inside the array. It's going to take the index of the inside the array. And then just to show you that it's there, I wouldn't usually use, actually, I will print this and I'll get rid of it just so you can see. But you can also throw into the map. The map has 3 different parameters. It has a callback function that uses the value, the index, and the array. Those are the 3 things that it can give you. So I'm just showing you all. The index, remember, is a 0, zero-based index. So I'm going to add 1 to it so everybody can see that this is going to be question 1. So let's see what happens here. Run that. So it says and it does show the 1. See, it says 1. This shows 1. Remember, I'm using the template literal, so I can just write it out like I want to see it. So I have the parenthesis here to show this. So number 1, what day is it? You can see that. And then it has a colon. and then it has the whole entire array. So if you actually wanted to do some other calculation or something with the array, you could use that. I'm actually going to rerun this without the array in there because I don't like how it looks. So I'm going to do this and rerun that. And actually, I don't need the array in there anymore. So I'm going to rerun it. All right. So it says, what day is it? I'm going to say Monday. First name. Sure. Right, so those are my answers. And if you can see, I'm console logging my answers, which it actually held all of my answers. Yeah, again, you don't need the parentheses, especially if it's a single parameter. I'm letting you know that it is much easier to read when you do, because when I see this parenthesis and then I see brackets and I don't see like this grouping my eyes together to think of it as a unit, it's the small stuff that really matters with code readability. So if you printed the number of questions, you kind of could have done that. But this is, if you're asking for like the graded assignment 1 with printing questions, you don't need to show what number it is. So it's just what you want. You could easily just do something like this that just shows the question. It says, what day is it? And it just returns whatever. So I'm just showing you mapping is something that you'll want to use. I think there's a filter one. I don't think I put the filter one on this live coding. I was thinking about it when I was not at my computer, and then I forgot about it. So filter's a nice one as well that you can do to arrays. Some people had questions about I think this actually stemmed from our last one, just being able to tell if something is even or not. And we had like true or false, but I think last time we realized that we can make a function that just returns this. So this there's the filter. So this is a filter that filters if this is true, then it'll return it. So returns the elements of array that meet the conditions specified in a callback function. So if it returns true, then it'll return it. Again, I could do something like this, and I could say value arrow function this. And to be honest, I think if it's just one parameter, you don't even need to pass anything in. Can't remember. Oh, no, I do have to pass something in. Oh, because I'm using value. Sorry. Yeah, because I'm using that, I have to assign what that is. I like this way better. Right. Some more. This one I kind of created. It's a little bit bigger, hopefully to show you some of the capabilities of this. So if I wanted to grab the total using a regular function, I can calculate the total using transactions here. And this thing calls my calculate, which is a normal function, like normally named function. It does use this reduce. The reduce requires, I wish it would show me I guess it doesn't like reduce well enough. But it takes a function, reduces it down. So we'll see this. Hold on, let me hit clear, get this out of here. Right, there we go. So this says calculate total. Total says, well, what is total? You're going to reduce it. Well, reduce it by every single time you're going to do your transaction amount and you're going to add it to the total. And then at the end, you're going to return that. And so what it does, it takes your transaction dot amount. This is something we have not seen before. I just wanted to introduce it to you. This is not something you're supposed to know already, but I can start taking things like an object. So do you see here, this transaction, that's a constant, meaning I can't change it once I set it. My transactions have descriptions and amounts in them. So if I put properties inside of an object, I can call just that property rather than the whole thing. So here I'm saying for each of the things in the transactions, take the transaction amount, add it to the total. And I'm doing the same thing with an arrow function here, all one line. I probably will, whenever I get my YouTube video up, I will paste this in with it so you guys can see this, because this has a lot of code in it that I'm not expecting you guys to have already seen. So I'll post that. Yeah, this is the timing one. Here's another one for timing. So let's say I have a greeting and the greeting's for everybody. So it says, hello, everyone. And then if I put in a name, I also want to greet an individual person. So if I say, if I do the set timeout, it says me first, and then it says everyone, even though I said to use the greeting first to call that, because I used the timeout thing, it came back late. So my name came first, then everybody. It's that timing. Code is executed in order, but it's not always returned in the same order. So here's how to fix that. Instead of doing just the timeout and me separate, and then my name separate, I could call a function, call the set timeout, and I'm actually going to pass it in lots of things. I think this one runs. Yeah. And I forgot to change hello world, hello everyone. I wish this was consolidated. Like on my screen, when it's nice and big, this looks all nice. Okay, I'm trying to. So the set timeout says, hey, call this greet and wait this long. I'm also passing in other arguments, which are these. So it says call greet for this long. These other arguments you're going to pass into the greet. And this is where JavaScript becomes very, in my opinion, confusing. Because these arguments, I didn't pass them in right here. Like I'm used to, I'm going to do this. I think this should work still. No. Thought it was type function. The screen is too, there we go. Map is only for array, correct. If you do strings and such, sometimes that it can use that as an array. Sometimes that's where me not being in JavaScript every day, I don't know all the capabilities of it. Right. Again, this is where I get just a little confused, because even I couldn't explain right this second how this Philip gets into this name right here. Because my set timeout is from some library. Set timeout, it says that I can do a handler, timeout, and any number of arguments that I want to pass in. So I'm passing in arguments, and I guess they go inside my function. In Java, that's the other thing, like whenever you're used to a language, Java never does this. Like Java would not allow this syntax. If there's 4 arguments here, there has to be 4 parameters going into it. So it's a little different, which is another reason why JavaScript uses callback functions a lot, where Java doesn't. Because everything is more synchronous unless if you force it not to be. All right, I'm going to pause just for a second. I can even feel that I'm losing some of you. So I want to make sure that we get regrouped here in a second. So let's just pause. I'm going to answer some questions. And then I'm going to go over recursive functions the best of we are. And then obviously we're going to get out of here a little early so that you guys can work on your graded assignment in Studio. Because again, I want to see each of you Thursday. So you need to get that stuff done. So questions? So the question, there is a question of like, things are getting complicated. Why do we have to get things so complicated? And to be honest, you can do basic things perfectly fine that don't really scale and not get complicated. If you want to make just a basic website, basic web application that's not going to have a lot of users, you can make that and not do a lot of the stuff that we just did, and you'll be fine. The problem is computer science is always trying to push the bounds of everything. So they're always trying to make better and newer ways to do things so that it's faster, more efficient, and not for us as humans, but for the computer. So always think, some of this stuff is not for us. It's actually for the computer to handle it better. So that's where my debate is, even with this whole chapter, is like, should we be going over this when it's lesson 6? Or is this something that we probably should wait a little bit longer to do? And the callback functions, you will see those, the arrow functions, you will see those even at a beginner level. So I think it's good to call them out. What we are doing right now is just adding tools to your toolbox so that you have different ways to do things. That's really what we are now. We went from the basics to now adding tools to your toolbox to do it different ways to make things either easier or faster or whatever better really means. So don't always think that these are replacing some of the things. They will in some cases, but if you just do loops instead of recursion, you'll be fine. And then we haven't even went into recursion. Yeah, JavaScript definitely allows you to call a function without explicitly defining parameters, which is crazy to me. Since we are taking a little bit of a mental break, does anybody know how to change the theme to maybe make it look better? I think it's under settings. Preferences. Oh, accidentally hit a button. Sorry. I saw theme. For those of you that have your screen up, I could just see all the white lights like popping up on your screen. Nice shiny faces now. Is this any better? I'm going to try a couple. Here's the thing. This is a mental break. Don't think that we're going to take a little bit of a mental break. We're going to play with this, have a little bit of fun, and then we'll get back to the recursion and then get you out of here. Let's color theme. I like dark, but ooh, not good. Not good. Dark high contrast. There might be a dark high contrast. Is it dark plus? Dark high contrast. Is that better? See visually? I mean, the color scheme's like ugly, but if you guys can see better, I guess that's fine. Hi. Hi. There was a lot of posts. I'm gonna scroll up for a second to see if I miss any questions, and then we got about 60 seconds and we're gonna get back into recursion. Hi. I hope I didn't miss anything. I think I tried to scroll through those. Right. As you can see, recursive functions. I'm going to try my best here to explain some of this stuff. I thought these were two different things. Okay, never mind. I will have to zoom out just a little bit because this is huge. So we're going to go back to the required read line stink. Right. All right. So what this is doing is that's that valid input thing. We want to make sure that their input is valid. What's kind of cool about this doesn't actually tell you what is valid. Like, what does valid mean? Does that mean it's a number? Does that mean it's a letter? Does that mean it doesn't tell you? Which is kind of cool with this function is it says get a valid input, but it doesn't declare what valid is. You have to pass in a function that declares what valid really means. So this is valid function, which this is just the parameter. It's not the argument that's getting passed in. It's saying if it is not valid, tell them it's an invalid input and ask them again. So I could have this get valid input be the same function if I was asking them if it was even, or if it was an odd, or if it was a string, or if it was, a multiple of 7, or if it was a negative number, or whatever it was. I get to decide what is valid, and I still use this same function every single time. So down here, we are saying is even with the modulus 2 equals 0, and that is the function that we are passing in that says is valid. So we're saying get valid input. We're passing in the original question statement, and then we are saying how to make it valid. So it says enter in a number. I say 1. It says it's not good. I say 2, and it's perfectly fine. I think there was a question on why is it return, like how does it print this 2? And that's because the console log is going to print whatever their user input is returned to it. But it's not going to actually return this user input until it's valid. So I'm going to change this up. Let's say is odd. That means this would be 1. So the same thing here is I get to decide what function it is. And to be honest, I can even do both of them. Is even, is odd. So you see how both even and odd are calling the same function to validate their input. And I'm going to rerun this. So it's going to do the even number first. I'm going to say, I don't know what an even number is. Oh, you mean this even number. Oh, and then it says it odd. And then I have to put it in odd for it to work. So the cool thing here is you can make a function, a validating function, and then actually pass in what it means to be valid. And so you don't have to keep writing, because usually you have to write this while statement over again and over again, like, because you have to usually write it once for, like an email address has to have an @ sign. So you got to check, oh, does the email address have an @ sign in it? Their age has to be a number. So you have to make sure that it's a number. Oh, their name should start with a capital letter. I mean, whatever you're validating is, you should be validating those things. And this is one way to have one function, and you just write the itty bitty piece that it has to actually check. Yes, I am going to be editing this. I'm going to show you a different way to do this. I'm going to comment this and show you a different way to do the same thing. I can't remember if I have input below, so I do not. So, all right. Here's another way of doing the same exact thing. But this one's using recursion. So you don't see a while loop anymore. There's no while loop. This says if is valid, return the thing. When we're talking about recursion, usually our base return statement is what we want. What does our end result want to be like? Well, the end result in this case is that we want the user input when it's correct. If it's not correct, we're going to say invalid input, but instead of doing a while loop, this actually recalls this function and says, do it again, do this function again. And if it's invalid, it says, do it again. And if it's invalid, it's going to do it again until it is valid. So this is one way that you could write a recursive function. Enter an even number. I can put in all the odd ones that I want. And then as soon as I hit an even, it'll break out of that recursive loop. So I'm just returning the same function. All right. Somebody said arrow function. Well, do you see how there's a function here? So instead of even declaring is even, I can actually take it and put it right here, and I say that's a function. Oh. I'm missing a. I think that should work. So enter in a number. Instead of saying is even, I can just delete that. I can say, I'm going to accept a number. I'm going to accept an input. I'm just calling it in. We're going to take the number that was inputted in, do a mod 2 and see if that works. I'm hoping this should work. If it's even, it works. If it's odd, it doesn't work. Till it's even again. So hopefully this is the type, like this is the general arrow function type. Because this is so small, I think you can even do this all on one line. I can't remember the syntax because I don't do it all the time. Yeah, there we go. Good guess. So this is an arrow function. This is probably the cleanest because you don't have to declare another function. If I said here I want an odd function, I just changed this to be 1 because any number mod 2 that gives me a remainder of 1 is an odd number. And then 4 is even, 1 is odd. So super clean. Again, I don't want to like overstress this, but we have every single different ability level listening in. We have people that struggle to get VS Code working on a daily basis to people that have already taken JavaScript boot camps before. So whenever I go over this stuff, I just want to make sure that I'm very upfront about if you know what level you are. And if some of this stuff is like, I know how to do the while loop, but I don't know how to get the recursive part, just do the while loop as long as it works. We're not in here to make every single person come out exactly the same at the end. This is a journey, and you're supposed to grow. That's what's supposed to happen. And to be honest, we just have a minimum standard of turning your stuff in when you're supposed to, such as graded assignment 1. So don't think that you have to learn every single little thing on the first time that you've ever seen it. Just know what level you are, have realistic expectations, but then definitely work your tail off to meet what we need you to do. And recursive functions is not one of them. So I'm going to comment this out. I was going to go over this. I'm a math person. It isn't this one. It's the Fibonacci. But anyway, whenever you do, this is one of those traditional recursive functions. So in math, there's a thing called a factorial, which is like 5 exclamation mark, which means that equates to 5 times 4 times 3 times 2 times 1. That's what a factorial in math is. It's used in a lot of statistical analysis. So if you're working on that kind of stuff, you need to know what factorial is. Otherwise, you don't need to know what that is. But that's what this function is supposed to do. It's supposed to take the 5 times, well, it's not going to be 4, but you're going to pass in 4. So n will be 4. So on the next recursion, it'll be 4 times. And the next one will be 3 times, and then be 2 times. But it actually works backwards because recursion goes clear down to the base case first and then pulls them all back out. So I'm hoping this will make sense. So at first, it calls 5, and then it calls 5 minus 1, which is 4. So it calls 4. It calls 3. It calls 2. But here's where it gets very weird. This one, yeah, this one won't work the way that the Fibonacci works really weird. Yeah, this one goes straight in a line, but it doesn't actually multiply them until it goes backwards. And it's hard for me to show that because you're returning the thing, which makes it hard for me to show what's going on. That's why this other one will work a little bit better for what I'm trying to show you. The Fibonacci sequence. So the Fibonacci sequence, if you've ever seen those, it starts with 1, 1, and then it adds the previous two numbers. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 3 is 13. So it makes a sequence of numbers based off the previous two, starting with 1, 1. This is the one. I've put these console logs because I was messing with this. So you can see how these get called. What this does is it says, hey, I want 7. So I'm going to call 7. Is 7 less than or equal to 1? No. So I'm going to do this. I'm going to print 7 again, but I'm going to return. And this is where it gets really weird because you're actually calling two functions. You're calling Fibonacci 6 and Fibonacci 5. So whenever you look at these, 7 does 7, which calls 6, which calls, and it always does the left one first. It's like a tree almost. And then once it gets down to 0 and 1, then it starts backing out, and then it goes back on the right side. It backs out. It goes back on the right side. Back out's more. Keeps going down. Keeps going back. Keeps going down until it finally gets 13. This is the reason why most programmers won't use recursion. It's more for mathematical, for statistics. When I was doing, like, because I've done a lot of high-level math, you have to do numerical analysis. You have to do computations of things that are too hard or too patterned. You would do stuff like this. But for computer science web dev, not seen it. So I do agree. Get a much better person on YouTube than me explaining this, and it'll make a lot more sense if you care to. Another one, countdown. So countdown says 5. Well, is 5 less than or equal to 0? No. So I'm going to print the 5, and then I'm going to rerun this to 4. Is 4 less than or equal to 0? No. So I'm going to print the 4, count down to 3, etc., and it's going to repeat through. So then you're actually going to have the countdown of 5, 4, 3, 2, 1. And then once it hits 0, it's going to print done. So it recursively calls itself. You guys can write this, and you guys should have the knowledge to be able to write this in a while loop. Instead of having an accumulator, remember how you add each time? You would have a decumulator. I don't know if that's a word, but you'd go down one each time. And so every time you run the loop, you just count down. And I would do a while loop while your number is, because we do have a little bit of time, I'm going to go ahead and do that. So I just do a while n is greater than 0, console log n, console log, what was it, done? I think that would work. Let's see. Oh no. Does anybody see what I forgot? I actually have to count down by 1 each time. because otherwise it was just printing 5 forever. Yeah, you got to decrease it. Yeah, you could do n equals n minus 1. Logically, n equals n minus 1 is logically where you should go. Once you've programmed enough, you usually see this more common. Does JavaScript use the n minus minus? Yeah, it does. So some languages use minus minus and plus plus to go either up by 1 or down by 1. Let me clear this and show this again without all the 5s. Yeah, so there you go. So a while loop. So most recursive things that are easy, you can just do with a while loop. That's why, another reason why I'm not a huge fan of it, unless if you're talking about very specific things. Got 2 more for you. Recursive again. I think this is the one. Again, this is so weird. It wants to add all the stuff in the array. So it does 1 plus, well, it doesn't do 1 plus 2 plus 3 plus 4 plus 5, which is crazy. So it does the array and it sets the index to be 0. And it says, is 0 equal to the array length? No. Else return the array at 0, which is 1, plus, and then call it again. So this is 1 plus, and then it has to wait. And then it redoes this thing with an array from 2 to 5. And then it has to wait, it pulls the 2 out, and it does another one of these with 3 through 4, or 3 through 5. And then the next time it pulls out the 3 and does this with 4 and 5. And then the 4 stays out. And then once there's only one element in this array, which would be 5, the index, meaning how many is in here, is equal to the length. And well, no, it actually pulls out the 5 because of how this is written. I wouldn't write it like this. I would do index equals 1 because you don't need the last one. But it goes through until everything's out of the array. And then once it returns 0, then it also picks up the 5, and then it picks up the 4 on its way back out. So again, I could rewrite this in a while loop or a for loop, to be honest, since we have the exact number. Let I equal 0 while I is less than the array.length. And then just have a total, an accumulator, and add them all up. So another one where you can do either way. And this is that reverse function. I'm not going to show this one. We've seen enough recursion today. So same thing, it goes backwards, but we know 2 other ways to write that. Again, I will share this code whenever I get my video and post it up. I'll post this because there is a lot of code in here. And if you have questions, you can ask me. It'll be all commented out for you. All right. I'm letting you out early. Any other last minute questions?